Convex lenses are used to form images on the opposite side of the lens. Here's an example of a convex lens, which is a glass device that will cause light rays to refract and converge after passing through it. When it comes to studying images formed by a lens, we should draw in its principal axis. This is the straight line through the middle of the lens along which light rays won't refract, and we can find the focus of the lens. Let's suppose we have some object extending upwards from the principal axis. In practice, the axis would pass through the object, but at GCSE, you'll only be seeing cases like this. Then, because of how light from the object will refract through the lens, an image of the object will form here. This is an image because there isn't really an object here. But if we held a screen here, then the refracted light waves would make it seem like there is. But how do the light rays from the object refract? And how do we determine where the image will form? Ray diagrams are used to determine how the light rays from an object pass through a lens and converge to form an image. Now, in an exam, you may have to draw a ray diagram from scratch, though you'll normally be given a lens and its principal axis to work from. Here we've replaced the convex lens with this symbol, which will make drawing the rays easier. You'll need to be able to recognise what type of lens this symbol represents. Remember that the arrowheads resemble how the convex lens curves outwards at the top and bottom. Let's now go through how we draw a ray diagram step by step. In step 1, draw an arrow from the principal axis to represent the object. By drawing an arrow like this, we're representing where the object is and how far it extends above the principal axis. In an exam, you'll only ever work from an arrow like this. Even if a question tells you exactly what the object is, all that changes is the label given to it. i.e., this could be a person rather than an object. You might also have to draw this arrow in using its height and its position, but it will usually be given to you. In step 2, draw a ray from the top of the object through the centre of the lens. Now, because of how the lens is designed, we assume that any ray initially directed at the centre of the lens will not change direction on the other side. This ray will refract when entering the lens, but then will undo this refraction upon leaving. So we can always draw this ray for any lens and any object. In step 3, mark the principal focus of the lens. The principal focus is the point at which all rays parallel to the principal axis will converge to. In an exam question, this may already be marked for you, or you may have to find it yourself by measuring along the principal axis using a given focal length. Then in step 4, draw a ray parallel to the principal axis to the lens and then through the focus. So if we were to draw a ray like this, which is parallel to the principal axis, then we know it must take this path after passing through the lens. This is because, by definition, any ray that is parallel to the principal axis must refract so it passes through the focus. In step 5, mark the other focus of the lens. Now, since the convex lens is symmetrical, there must be a second principal focus on the other side of the lens. Again, this may be given to you, or you may have to mark this yourself. This can be done using the fact that both foci must be the same distance from the lens, or you can find it using a given focal length. So in this case, the second focus must be here. In step 6, draw a ray through this focus and then parallel to the principal axis after passing through the lens. Again, since the lens is symmetrical, any ray that's parallel to the principal axis on the right must pass through the focus on the left. It doesn't matter which direction it's travelling in. So we can draw a ray from our object through the focus, which will then travel like this, since it has refracted, so it's parallel to the principal axis. And finally, step 7, draw an arrow from the principal axis to where the rays converge to represent the image. Now technically we could have done this after drawing only 2 rays and seeing where they cross, but drawing the third ray and making sure it crosses here too is a great way of making sure there aren't any errors in our diagram. So we've shown that light rays from the top of the object meet at this point. This tells us that the top of the image will be here. We draw the image as an arrow as well, as the important information is where it is and how far below the principal axis it extends. Make sure you have a good understanding of this process, as nearly all exam questions about lenses will include either constructing or completing a ray diagram.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!